The Encon upgrade is including two EIPs for consensus client improvement. As a validator, general enthusiast, if you would like to follow the upcoming changes to the state transition function, continue listening. Hey everyone, this is PEEPanEIP episode 114. I'm Pooja Ranjan. In this Dencon special episode, we are going to be talking about EIP-7045 Increase Max Attestation Inclusion Slot. Documented in May 2023, the proposal is currently in draft status. To talk about the proposal and explain what changes will it bring to the Ethereum mainnet, we are joined by a very special guest whom you must have seen in dev meetings and events talking about Ethereum consensus layer. Let me welcome one of the researchers, All Core Dev Consensus Meeting Coordinator, and the author of the proposal, DannyRyan. Welcome back, Danny.
Hey, thanks for having me.
For our new followers, Danny has been generously taking out time to educate the community about the upcoming changes. We have had him in the past talking about EIP 2982, Altair, the first beacon chain upgrade, so on and so forth. I'm so excited to have him back on the show to talk about the latest Dencon proposal. But before we get there, I request Danny to briefly introduce yourself and share your journey in the Ethereum ecosystem.
Yeah, so my name is DannyRyan. I work with the Ethereum Foundation on the research team. So I do some research. I've done a lot of specification writing over the many years, and I do a moderate amount of coordination mainly with the consensus layer side of things, but just kind of across the development effort in upgrading Ethereum mainnet. 2017, I decided Ethereum must be my job. So I gave myself a year to contribute to open source things and just figure out ways to get involved. I got heavily involved in the proof of stake effort during that year, thinking it was imminent, started helping out there. And since then have worked on all sorts of things related to proof of stake, related to scaling, related to Ethereum security. It's been a fun journey since then.
Awesome. Very well. Thank you so much for this brief introduction. I'm aware that we have got a presentation for today's proposal. So without further ado, let's peep in.
Great. So EIP-7045 for PEEPanEIP. I did give a brief intro. Those are my handles, DJR2 on a lot of platforms, DannyRyan on a few like Twitter. Like I said, research, specs, coordination, all sorts of things and helping Ethereum mainnet. Cool. So I want to kind of start with some background, make sure we're on the same page. On the consensus layer, we have two primary data structures. We have blocks and we have attestations. If you're familiar at all with blockchains, that's what blocks are when we're talking about them in the consensus layer. They form a chain, they reference each other, they have all sorts of data, transactions, all sorts of good stuff. We also have this very important data structure called attestations, or sometimes called votes. And votes or attestations, every time there's a block, so every slot, every unit of time on the consensus, the Ethereum proof of stake chain, one proposer produces a block, but many validators are invited to attest, to say what do they think the head of the chain is, to kind of throw their weight into it. So they make all these little messages, they're the circles, and vote for a given slot what they think the head of the chain is. These votes can be included in subsequent blocks. Note, this can be confusing if you're not used to blockchain diagrams. Blocks reference their parent. So the arrow points backwards. Time is actually moving from left to right. So these are subsequent blocks. These are children or descendant blocks of what was voted on. So these little circles here, these attestations can be included in subsequent blocks. That really forms the core of like the consensus. These two data structures, they're so critical. You know, the block proposal comes up and says, these are the changes, these are the things that are going to happen during the slot. And then other validators come in and say, yep, I saw those, that looks valid, that looks good, I'm happy with that. Importantly, we often talk about blockchains, obviously, but we actually have a block tree. So we can have any number of like forking. So we can have conflicting proposals. So for a given block, you might have two potential descendants. And so what we take this block tree and we actually try to form a blockchain, the one single canonical history. So given a block tree, any of these, the green, the purple, or the blue, might be seen as the canonical blockchain, depending on your view, the algorithm, et cetera. And so what we use in Ethereum proof of stake are these combination of two algorithms, one called LMD-GHOST and one called FFG. LMD-GHOST is latest method-driven, greedy, heaviest observed subtree, and FFG is the friendly finality guided. So LMD-GHOST kind of deals with the tip of the chain, and FFG deals with finalizing checkpoints forever in history. And so when we look at LMD-GHOST, this is called the Forkchoice, fork meaning which branch in this tree is going to be canonical. We use a simple algorithm that takes these attestations and assigns, each attestation kind of assigns weight recursively to the branch. And so really we sum up these attestation weights and we get to a chain tip. So right now, this one in the middle has 17 total at the tip. So that tip recursively defines a whole chain. That's our canonical chain. The thing about LMD-GHOST is that it can reorg. So if you get new information, you get new blocks, you get new attestations, all of a sudden you can find a chain tip that has heavier weight. And so what you thought was embedded in the chain, what you thought were user transactions that were going to be confirmed might actually change. Your view can change. And so anything in this kind of LMD tip is subject to potential change. The nice thing is that we can finalize segments. We can finalize these checkpoints at some depth in a chain. And once we finalize, we don't have to think about the rest. We know that that will never change. And so the rest of these things that are divergent with finality, actually, this block should be finalized, not this one. I apologize. Pretend it says finalized right here. Actually, let me fix it. Back in action. So if we finalize this, anything divergent, any chain that doesn't include this finality is no longer fair game. And so we can't have reorgs past this depth, which is really nice. And so that's the difference between kind of FFG and LMD. LMD is how do I past finality figure out what the chain tip is? How do I, and then FFG is like, what are these like fully locked in segments that have full security? Another important part about the mechanism of these blocks and attestations is attestations can't be included forever. There's this inclusion window. So at slot n, attestations happen. And from slot n plus 1 to n plus 32, those attestations can be included on chain. Normally in mainnet, like most of the things that happen in n just get included in n plus 1, but in very exceptional scenarios, you can have these attestations filter in for up to 32 slots. 32 slots is how long an epoch is, which is kind of like a large unit of work in the Ethereum proof of stake chain. And this is rolling. So like this attestations for slot n can be included from to n plus 32. Attestations for n plus 1 can be included all the way up to n plus 33. So you have this kind of rolling window for a given block, for a given slot, when attestations can be included. And that's really what we're looking at in 7045 is modifying this window. So this in the proof of stake spec, which is a bunch of Python code that rigorously defines the spec, we can see in the state transition, attestations that are included on chain are verified via this function process attestation. And if we look right here, we can see the kind of the window, the min and the max. So min attestation inclusion delay is 1. So the attestation slot plus 1, it can be all the way up to the attestation slot plus slots per epoch, which is that 32. And so that one line defines this window. This window was decided before the phase 0 launch. So before kind of the proto beacon chain got into production in 2020, it was decided to put this window as most of the spec at that point. And it was decided because this window seemed fair. So for any slot that you created an attestation in, you get 32 slots of inclusion, of potential inclusion. So it doesn't matter if you're at the start of an epoch, the end of an epoch, you always get exactly 32 slots of this rolling window where your attestations can be included. So it's just kind of like it seemed aesthetically pleasing that you didn't have asymmetries between the beginning and end of the epoch, but not really a strong security argument for why this was the case. Not an argument, we didn't find an argument against, but it was more just like, okay, that seems right. That seems okay. There was this counterfactual inclusion window that we did discuss at the time. Essentially, if an attestation is created in epoch X, you could include an attestation in all slots remaining in epoch X and all slots in epoch X plus 1. This was seen as less fair because if you were assigned to a slot at the start of epoch X, you could get almost 64 slots. You get all of X and all of X plus 1 for inclusion. Whereas if you were assigned to a slot at the end of epoch X, you could get more like 32, 33 slots because the end of epoch X, there's almost no time remaining. and then you only have x plus 1. So you get this kind of asymmetry between like where you were assigned in an epoch on like how long it takes to get your attestation included. And importantly, if your attestation is included on chain, you get rewarded positively. If you don't, then you can get a penalty. And so we were kind of like, that seems unfair. It's a weird asymmetry. Let's not go that path. But there wasn't like a strong reason besides this kind of aesthetic fairness reason. And note, when we think about it today, we realize that like fairness matters within an epoch, but it really matters over like many, many repeated epochs. Because if you're a validator, you're constantly doing this roll over and over and over again. So even if there's an asymmetry within one epoch, you play this game over the course of the day, course of a week, course of months, which you do as a validator, it's fair over many repeated executions. So the fairness argument wasn't even that strong. So that was the alternative we considered at the time. And EIP-7045, TLDR, you learn nothing. It's swapping from the original inclusion window to this alternative. So, and there are good reasons to do so that we learned since then. So this window of the slots per epoch to this window of any slot within X and X plus 1, where the slot is greater than the attestation. And again, this is pre-EIP-7045. It has this bound from slot plus 1 to slot plus 32. This is the whole change of the EIP in the next slide. It just doesn't have the upper bound. Note that this line, 2 lines above, which was there in both, makes sure that the attestation is from either the previous or the current epoch. So we kind of get that X and X plus 1 bound already. So we just reduce this condition. We make sure that it's at least older than the slot it was created in, so we get plus 1. And then we're bound to both epochs from this previous line. It's probably about as simple of an EIP, about as simple of a change as you can make to the state transition function. In terms of testing and the consensus test, this was conditionally modifying a test at this boundary and adding like probably 2 or 3 tests to really cover some of the edge cases here. And note that this is the state transition function. There's also the P2P gossip conditions, upon what condition is a node allowed to forward these messages to its peers. It also had this slot bound, the same 32 slot bound. We also have extended that in the P2P gossip condition. So essentially this condition mirrored, but when you're deciding to forward a message to your peers. So that's what's going on, but I didn't give you much of a why. So as we discussed at the beginning, FFG finality confirms things every approximately 2 epochs. An epoch is 32 slots, slots are 12 seconds. So an epoch is 6.4 minutes. So we're talking about finalizing and really confirming and like being able to make decisions about what's included in the canonical chain every like 13 minutes almost. And that's to get things with that maximum security, which is great. The beacon chain is very secure. There's a lot of crypto economic capital validating it. And so we get like a very high security threshold on these finalized tips. But until then, we don't have much assurance as to what's going to go into the chain. And so before finality, we have this LMD-GHOST thing. And as we pointed out, it could potentially reorg. And LMD-GHOST analysis and potential confirmation rules, and I'll get into that, it's been kind of elusive. It's been actually kind of a major pain point in the analysis and the understanding and the extension of this proof of stake protocol. Essentially, under what conditions am I confident that this block tree is not going to reorg, right? Other than not taking into account those finalized checkpoints, can I just looking at this block tree figure out using LMD-GHOST what's not going to reorg? And that question's been tough. We've been beating our heads against the wall on that question for a long time. And so let's look a bit more when I say confirmation rule. Obviously the confirmation rule of FFG finality is like maximum security. That's a good confirmation rule. It just takes a long time. But the confirmation for LMD-GHOST is, can we add additional assumptions that if they hold, blocks in LMD-GHOST cannot be reorged? So such assumptions might be synchrony. FFG is asynchronously safe. So I can get messages from 5 minutes ago, and I know when I finalize something that I'm safe. Whereas, can we relax that? Can we say, under normal mainnet conditions, I'm very confident I get all my messages within a slot or within 2 slots. If I make that assumption, as long as that assumption holds, can I confirm things? Can I make stronger assumptions about the honesty of the set? Can I make or construct rules that require really high onlinedness? Like you only really need 2/3 online to finalize something in FFG. But what if under normal mainnet conditions, we have like 95% online all the time? What if we assume we had greater than 90% online? Can we confirm something quicker? And so for the past few years, we've been seeking an LMD-GHOST confirmation rule and playing with, can we make more assumptions to try to get these confirmations, faster confirmations? So fortunately, at the beginning of the spring this year, these 5 people locked themselves in a room and didn't come out until they figured out a confirmation rule. So this is a few people from the Ethereum Foundation, Aditya, Francesco, and Luca, very strong consensus researchers. And then a couple of people from Consensus, Roberto and Chen Yi, who are very strong consensus researchers and form verification engineers. And they did it. They beat their heads against the wall until they came up with a confirmation rule that works on Ethereum mainnet for LMD-GHOST, which is extremely exciting. I'm not going to get deep into that confirmation rule, but if you would like to dig a bit deeper, here's the ETH research post, the QR code that kind of explains it from a high level and links to the deeper paper. And here's an explainer blog post that Aditya wrote that has some really nice diagrams and can kind of walk you through how it works out with, rigorous, but less of that kind of academic paper approach. Check it out if you're interested. So the TLDR on the confirmation rule is that in normal mainnet conditions and reasonable assumptions, we can confirm blocks in 3 to 4 slots, which is really, really exciting. I can get some semblance, some understanding of if something's going to become canonical on the order of like 30 seconds to a minute. It does, to get those fast confirmations, you make a 1-slot synchrony assumption. And to get those fast confirmations for it to really be kind of like functional, we want to see like greater than 99.5% blocks and attestations. So missing blocks and missing attestations reduce the efficacy, the confirmation rule. And importantly, all of these values can be tuned. So if you're not willing to make the 1-slot synchrony assumption, you can make a 2-slot synchrony assumption. If you're not willing to make certain onlineness or honesty assumptions, you can change those. That's going to make it take longer, but it's going to be a stronger confirmation. So, maybe you're on the order of 5 minutes, you're on 3 minutes instead of that 30-second window. Very importantly, the security analysis of this confirmation rule requires the alternative attestation inclusion window that we've been discussing. And the intuition there is essentially you need to be able to, so we can do FFG confirmations all the way through the end of the next epoch after an attestation. And if we observe something on the P2P, we want to have stronger assurance that it can actually make it on chain. And so that's kind of the intuition here. But again, if you want to dig deeper into it, please check out these posts. But we need that alternative inclusion window, thus EIP-7045, because EIP-7045 essentially enables this confirmation rule, this long sought after confirmation rule. It's extremely exciting for UX, and it gives applications different kind of decision points. So if I have a really high value application, maybe I'm at an exchange and I'm processing deposits of like $1 million or $10 million, I probably am going to use FFG Finality. But if I'm that same exchange and I'm processing a $50 deposit, I can then use this fast confirmation rule to enable like a much higher and better UX for my users, which is really cool, right? Like I now have like a spectrum of confirmation and security and assumption that I can take as an application, and even with ratcheting up those assumptions for the confirmation rule, the synchrony assumption, the honesty assumption, I can also have gradations of that as well. So, that dApps, all sorts of other things, and wallets, anything that kind of like shows you if things are confirmed and allows you to do things with respect to capital, with respect to assets, or respect to kind of anything, they now have this alternative. And so we're really excited. The specification of the confirmation rule is nearly complete. There are some proof of concept implementations. We're really excited to have DannyR go live to enable the confirmation rule and these specs to be finished such that we can start knocking on some doors and say, hey, give it a shot. This has these different security properties from FFG. This could enable better UX for certain types of users and applications. Yeah, that's it. It's swapping that window. It's a 1-line change in the state transition function. It's motivated by having a better confirmation rule, which was found by those researchers in the spring. So it's kind of as of now, it's going to go into DannyR. Obviously, nothing's in mainnet until it's fully done, fully tested, and actually deployed. But it's about as simple as it can get, and it was really exciting. Questions?
Awesome. It was a wonderful presentation. I mean, explaining tech is challenging, but you did a great job representing the blocks and explaining the concept. I hope it will be helpful for many others to understand what we are trying to do over here. I have a few questions for you
Great.
that I would like to touch on. First, I want to understand the main challenges, if there were, at the time of beginning of the beacon chain, because I'm assuming this is what we are doing with 7045 is improving the original beacon chain.
Yeah, so a lot of time, a lot of thought, a lot of research kind of went into designing the original beacon chain. But until the system got live, there were unknowns, right? So certain like UX pain points, certain security trade-offs and different things like that, that since a lot of the original designs, which people have been working on designs since like 2014, 2015 in early research, really the full beacon chain and thought like around how to construct it was started in 2018. It was deployed in 2020. It's now 2023. We've learned a lot, right? This is like this is the highest value proof of stake chain in existence ever. And so there is just a lot of learning to be done. And so, you know, this idea of fast confirmations wasn't even really something we were talking about 5 years ago, whereas it's become like a very important UX point. And so it's then become like a certain research direction. So then all of a sudden you have this live system and it realized, okay, if you make this little tweak, it can make it better. And so there are a number of proposals from small to large like this that are researched and debated and will be for the next few years, really because we've realized how to refine this live system. Obviously, like changing a live blockchain is like no joke, both from a technical standpoint and a social standpoint. You know, changing the promises that have been made and the expectations and understanding of the system is a big deal and a challenge. Fortunately for this kind of thing, this is purely a security improvement. It does not affect the UX really of anyone. If anything, it makes it slightly better to be a validator because your attestations can be included for longer windows sometimes. But yeah, it's a lot of us worked on this thing for many years. We did our best, and there's still a little bit of work to do and some refinement to do.
Great, thank you. If I remember correctly, I have heard about single slot confirmation of the blocks on the consensus layer. Is it something like proposal 7045? Is it something moving in that direction, or those are separate?
Yeah, so there's a research direction called single slot finality. Essentially, right now we have multi-epoch finality. It takes a long time to get all the validators to vote and agree on something. Single slot finality is a research direction to try to figure out ways to get all of the validators to be able to vote every slot, either by having much more efficient networking constructions, more efficient consensus cryptographic constructions, reducing various types of load so that we can process more votes in a single slot. And this is a really nice UX improvement if it ever goes through, because instead of getting these LMD-GHOST confirmations, which can happen on the order of a few slots, you could get full crypto-economic confirmations on the order of a slot. This like kind of dips our toe in the UX direction, having a better UX, but it doesn't fully make the deeper changes to the protocol that single slot finality or SSF would bring and require to get those kind of full cryptoeconomic confirmations. But similar work streams, essentially like what methods and techniques do we have to get faster and secure confirmations? But this is like the really easy tweak that gives us something rather than a much deeper change.
Something that can help us for like very less code, but improve the feature. Awesome. I was going through the proposal and I came across something called specification constant. It seems that the value is not added. So I'm curious, like, is it still in a discussion, or how are we going to decide a constant value for that?
So I think the only constant that's in this EIP is the fork timestamp. And that we would just essentially whether explicit or implicit for any core EIP that goes to layer 1, you have to have kind of the coordination point. And so the fork timestamp would be for the fork as a whole, and it would turn this feature on. And that would be in the event that it goes to mainnet, which it looks like it's going to, and we are kind of towards the end of forking the public test nets, then core devs would decide on like when is the proper time to fork the test net. So there's a fork mainnet and to fill this constant. So I think that's the only configuration value that's in this one. Depending on the spec, sometimes we have configuration values that we're unsure of, like for example, 4 the amount of like blobs that can be included. And in that, when we're unsure, we're doing a lot of like testing, research, pen and paper, running mainnet experiments, that kind of stuff. But this one doesn't really require that.
That is good to know. But this is something different that I have never observed for any core EIP, so it caught my attention. Like in specification section, mention of the timestamp of fork. It was
Oh,
like,
interesting.
yeah,
I've seen that maybe, I feel like in 2017, 2018, that was like fork timestamp or fork block was included more. And so I'm just like a old timer at this point and using that. It's not really that important. Essentially, it just says
right.
at point A, time in point A, B, like this feature will not be enabled. And then at some point that we have to decide, the feature will be enabled. Right.
Right. I'm not 100% confident. Perhaps this value might have been in the meta file, meta EIP, which was at the time for upgrade considered. But since we are not following meta EIP anymore and
Yeah,
everything
maybe
is
so.
maintained separately. So yeah, but good thing, no problem. I found another piece of information which suggests that the spec removes inclusion delay. I'm assuming it's redundant. Is that the reason?
Yes, when I was looking at some of the code snippet, these are the validation conditions. First, we take the attestations data and we make sure that the epoch is in the previous or the current. So that really means like if the attestation was created in epoch X, is it X or X plus one? And so that puts a maximum bound already. Because once you enter X plus two, you can no longer include this thing on chain. And so, but previously we had a tighter bound on the slot because of this plus 32 right here. And so because we already get the epoch bound, which we want to be the maximum bound, we really just have to remove the upper bound on the slot. And so by removing the upper bound on the slot validation, we fall back to the epoch validation, which becomes our upper bound. And so, yeah, if I would have put like the slot and actually calculated the slot dynamically of what the current epoch is, that would have worked, but it just would have been redundant with this condition right here already.
That makes a lot of sense. I have a few more questions with respect to specs. I'm curious if the latest CL specs include EIP-7045, and if so, what is the version number of that?
Yeah, so the consensus specs repo, and we have releases, and releases only happen when things actually go to mainnet. So the latest release is V130, which is actually the mainnet release for Capella, which was the last hard fork. But if you actually look at all of the releases, we have pre-releases. And so V140 and all these alpha versions, beta versions, these are not actually going to mainnet, but they're test versions, pre-releases that are on testnet and for discussion and analysis. And so as you can see here, the name of this spec was Consensus Spec Tim's Vision because he wanted to use consensus layer EIPs, and here we finally are, consensus layer EIPs. At this point, the DNEB spec, which is the name of the next hard fork, it only had 4.4 in it for initial testing. We've added these three EIPs to this pre-release. So 4788, 7045, and 7044, which 4788, those aren't too relevant, but these are the what those EIPs are. So it is in the DNEB pre-release. So it is in what everyone's working on for development for DNEB. Like I've said multiple times, until this is a V140, the official release and the final release and things have gone to mainnet, will we say that it's finally canonically kind of embedded in there. But V.1.4.0, when it comes, will be the kind of the final version for DNEB.
Got it. Yeah, that's helpful because CL has always been a leader here for this kind of experimentation and getting the specs added for testing purposes. I think this is useful and new information for people on the EL side. I have a similar question on the same topic here. Like for EL, we generally look for the EIP's implementation, the client implementation. Are we aware, like now that is added in pre-release spec, how do we know that which all clients have implemented this proposal?
Great question. I know that it's being tracked. I don't know exactly where it's being tracked. Right now, it has been verbally agreed upon in the consensus layer calls and in the execution layer calls that not the current DevNet, which is only 4.4.4, but the subsequent DevNet, which I believe is DevNet 8, will be full featured, which will include the additional EIPs on both sides. And so because of that, we have a strong signal that the consensus layer teams are working to that full feature set, this latest release, and we'll be ready for DevNet 8. I know that some of the DevOps folks that help run the DevNets do have documents tracking readiness. I don't know if they have a document for DevNet 8 yet, but it's being tracked. It's a good question though, because I know on the execution layer side, there's been a bit more rigor in tracking kind of readiness in different tables and stuff. It's something definitely to consider as we approach Deneb if we want to do the same thing.
Yeah, I think that would be helpful, especially for people who are not so very technical, but they want to keep a close track
Right.
of how we are making progress. I'm not sure if this is a practice for consensus layer as well, but I'm just curious. Do you guys consider having a folder for every upgrade so other people can just go click to that folder and will get to know about what happened, what went inside like that?
Yeah, let me give you a view. So here are the consensus layer specs repo. We can go look at the main README. The first thing that happens in the main READMEs are the stable specifications, which generally are like the forks, the hard forks. So we have phase 0, the relevant documents. We have Altair, Bellatrix. Note that these after phase 0, they're names of stars and they go in alphabetical order. Then we have Capella. These are all the things that are on mainnet. And then we have in development specifications. So Deneb is that next fork. So people can check out all of the different spec changes here. And then we have a lot of different like feature forks, just independent features that people are experimenting with. So if you actually look at the specs folder on this repo, we can see first and foremost, these are the big upgrades. And so we can go to Deneb and we can look at all the different files related to Deneb. If we go to the beacon chain, the nice thing is everything's annotated by the EIP. So if I want to see the 4844 changes, I can just search 4844 and I can see new in Deneb, these little annotations, this was modified in Deneb, whereas this feature of this data structure was added new in Deneb. Similarly, 745, I can hone in on annotated, what are the exact changes here. So that's how those are organized. And then if you are looking for the features that are not slated for a hard fork, but are currently under kind of people are working on doing some R&D on, we can go into here and we can see, EIP-6110, which is a potential feature to change the way the deposit flows work to make it more secure, or 7002, which is to add execution layer triggerable exits. We get this nice kind of subfolder that, if you're not involved in R&D, you don't really go check it out. But if you do want to see like some of the features that people are working on, it's in this underscore features folder. But the main specs are these folders that are named after the stars.
That's great to know. I mean, I can see that it has been meticulously organized here.
It's a work in progress.
Right.
The consensus specs for years were really the Wild West, and they were built for the people that were very actively building. We've been more and more trying to up our level of documentation and kind of make it more inviting for people to be involved. So if there are particular pain points that people run into, let us know, because we don't move fast, but we're trying to make it better over time.
Of course. Yeah, my general suggestion here would be if in the particular upgrade file, if we can have a README section and had that table.
I've been thinking about that as well. I'm like, I need every single one of these folders needs a README. I totally agree, and I just haven't done it. But if anybody listening wants to make a README, the first README for maybe like even the Deneb, just list kind of the high level things, I will accept that PR. I will do a deep review and help you out and get it over the edge.
Of course, we'll share this message out. I am curious about, I know this is not the proposal that we are discussing today. I have the meeting planned for this later on, but I found that in the spec 4788, is it going to be for both clients like consensus and execution, or is it just execution specific?
Yeah, so that one's, often now that we have this kind of merged system, we can have features, EIPs, changes that only affect one side or the other, right? Like 7045, it only affects the consensus layer because it's just that attestation inclusion window. The execution layer knows nothing about attestation. It's just totally self-contained in the consensus layer. Whereas 4788 is what we call a cross-layer EIP, which requires more coordination, requires more testing, is a bit tougher. And what that one does, it's primarily the heavy part of the load is on the execution layer. They have to kind of add this new precompile and expose things and do some state updates. But there is a small change on the execution on the consensus layer, and that's to like essentially there's this root, this commitment, and it's to make sure you pass it into the execution layer. So it's very small. It's just like give the data to the other side. But it is cross-layer and does require some testing and specification on this side. Whereas again, on the execution layer, you can easily have EIPs that don't affect the consensus layer. Like if you added a new opcode that did modular arithmetic or something, like the consensus layer wouldn't have to know or care about that. But these cross-layer EIPs, they're definitely require more coordination and more agreement and more testing. They're a bit tougher.
I understand. We recently have a chat with Mikhail and team for 6110. So we understood like that kind of proposal are for cross layers.
Yeah. Anything cross layer is tougher. It's like 7045, that EIP was written, I don't know, in the spring at some point, and it was like very quickly like, okay, let's just do it. Whereas if it was cross layer, even if it was small and cross layer, it would have been much harder to kind of get in at that point of the process.
Yeah, we totally understand that. We want enough time for testing and other things. So make sure, like as you mentioned in the beginning, it's no joke changing the running multi-billion chain. Yeah. All right. I didn't see anything mentioned over there. Just for confirmation, is there any security concern that client teams or perhaps the validators or users of this, implementers of this proposal may be aware of?
Yeah, no, I mean, this is really other than the fact that if you change things, you have to do lots of testing, right? Even tiny changes. So that the security concern is making sure it's correct, but it's extremely simple. And all of our security analyses tell us right now, it's strictly an improvement in security. As for people operating validators and operating nodes, it's going to be totally transparent change. They're not going to really notice anything. It just is to help enable that confirmation rule. So the big thing is it's a positive change for security. And I really hope, call it by the end of the year, that some exchanges and other high value, other applications that kind of expose confirmations to users, that they start incorporating this and have a better UX. This I think is really exciting.
Right. Yeah, UX is always helpful. Like better UX is always helpful for novice users. Like even if big parties are doing that, many of them will be helped with that.
Yeah.
All right. I think that concludes all my questions related to that, like specification and technical aspect of the proposal. Now I want to get into a little bit of documentation of an EIP, because we have been in discussing the ELCL kind of thing, like EL people are doing EIPs and CL people are doing it for the first time. And I know you are a veteran author. You have written multiple EIPs. So generally curious, did you observe any significant process change?
Yeah. I mean, so I have written EIPs in the past, but most of my specification work over the many years has been really contained into that consensus specs repo, which does not contain a lot of exposition or explanation. It's really what is the Python code that modifies the state transition function. So that's most of what I do, right? And we've made an effort in this fork to, now that the merge has happened, to try to unify this process and write EIPs and better document all of the changes going into the consensus layer. Tim Bako really pushed for this. People on the consensus side were a bit skeptical, but I think it's going really well. And it's really nice to have a self-contained chunk documented, given a name, and being able to be like kind of discussed, debated, and tested independently. This is very contrary to, like, if you look at Altair, which was the first beacon chain hard fork, it's like kind of hard to parse what's going on. It's kind of hard to parse what the different features are, and you really kind of need to be using extra blog posts, maybe your PEEPanEIP series, to really like understand what's going on. Whereas given the EIPs and given these kind of self-contained documents that accompany our spec, we can just say 4844 goes in, 7044, 7045, and 4788. And they can go look at the names, they can look at the abstracts, or they can look deeply at the specs. And so that's really been a big process change for us. So it kind of depends. Sometimes people will still write a consensus spec update kind of as a draft with no full EIP, just kind of quick and dirty. But once we've really are elevating it into discussion, then we now are going into the EIPs repo, writing an accompanying document, which gives the high level motivation, the abstract, and kind of the high level of the really nitty gritty specification change. But then it links to the consensus specs, which then have the like mechanical change to the state transition. And I've actually found this really nice. I was a bit skeptical, and I've quite enjoyed it, especially for these cross-layer EIPs. It makes a ton of sense because, like, things are happening in multiple places, and you really just need to like have a single kind of source of truth and a single place to kind of jump into where they're happening in multiple places. So we're still kind of, it's still an experiment, it's still a work in progress, but we're honing in on some standards on like, you have you bullet point the high level changes in text and you link out to the specific places, and then on the consensus layer side, as I showed, we have a bit of like a format and annotating, the different line changes that are relevant to the different EIPs. But I think it's going nicely.
That's quite helpful. I was having a chat with the tap line for 7044. He also mentioned that though he was not very much convinced that an EIP is needed, but now he can see the value for, especially for non-technical people, in having an EIP. While sticking to the same topic, I have a few things to discuss about the EIP documentation. We generally encourage people to have a discussion to link, to share information about the proposal and also invite community participation. They can let know how comfortable they are or not. I did see the discussion to link for all the CL EIPs, but I did not see anything happening over there. Is there any other place where people can follow the discussion?
Yeah, as I linked in the presentation, there is also an ETH research post that initially presented the confirmation rule. So that's kind of a place where discussion can happen. I think really what happened is this is just extremely simple and was agreed on relatively quickly in the core dev calls. And so just didn't have much discussion. I guess one place where discussion does happen is, I can share my screen one more time, is when we're doing the kind of mechanical change to the consensus layer spec. Like this is the PR that introduced the change. We have this modified line right here. Like there ends up being some discussion in these inevitably because people review these PRs. So, POTA has jumped in and just made a small typo change. Terrence is making a note about how we've done things in the past, just nothing crazy. But I would say if there's any conversation, the bulk of it happened in this PR, which is interesting. It's interesting to note, anything that bubbled up from this, that say somebody brought something about security or this or that, it would ultimately get reflected in some of the discussion notes on the EIP. But it is interesting that these PRs aren't kind of like directly linked and thought of in there. Something to think about. Work in progress, like I said.
Right. No, I understand totally. Like that was something that people used to do back in 2015 to 2017 era. But we generally recommend people to have any kind of discussion in FEM. The reason being, once the PR is closed, once the EIP is merged as a draft, you will come up with new PR to have the status change. And in that case,
Certainly.
people may lose the context. So I think for transparency and giving full context of the proposal, like what, when, why, how, everything, it's useful to have some chatter around Fellowship of Ethereum magician.
I wonder if like any PRs should be like at least linked to in the magician's thread or linked to on the EIP, because there's also like part of what we're doing in the consensus specs when we're doing reviews, like we're literally reviewing code, we're literally reviewing mechanized code, and like GitHub's very good at like kind of having that all linked together. So I don't imagine we're going to depart from having some of these discussions in the PRs, but having them appropriately linked somewhere might make sense. I'm actually going to drop it in the magician thread right now.
Yeah, that would make sense. In fact, if you add the ETH research post as well, people will get more context of what is going on in here. And every time if any spec change is happening because a new PR, someone did something, that we can definitely link it back in the Fellowship of Ethereum magician so people can have a regular updates there. Okay.
Cool. I'm going to drop it in there. Cool.
All right. I know this is the first time that CL people are doing it. So
we're figuring it out.
little bit. Yeah, I suppose a little bit of nudge will help all of them. And talking about that, I understand that this proposal, as you mentioned, may be a part of pre-release spec, right? But I see the proposal is still in the draft status. So earlier we did not have the review status. So from draft, it was supposed to go to the last call. And in that case, it makes sense if you want to keep it in draft. But now there is a review status, which is generally helpful because, EIP editors will pay more attention. Even community will start paying more attention when they find it in review status. It's a small PR, just you need to create saying change of status from draft to review. But I think that would be the most appropriate.
I'm going to do it right now. I've written many EIPs, but I'm sometimes a noob to the process still. So yeah, very useful. When you said it was drafted at the beginning of the call, I was like, oh, that sounds wrong.
Right. Because
so
we are
review.
very close to the upgrade. Yes. Review is the best one. And when it moves to the public testnet, then we move it to the last call status.
Sweet. It's done. Or well, there's a pull request.
Awesome. Thank you so much. And a last question on this one, like the governance and the process improvement. If you have noticed anything that you see is not relevant with respect to present EL and CL client having the same kind of documentation, what we call is like unified documentation process. If there is anything that we should get rid of, please feel free to share, and we'll try to have that proposed in the next EIP meeting and try to work over there.
That sounds good. Yeah, we're getting used to it. It's not so bad.
I think your nudge for change of process works a lot. I remember seeing an issue created by you about the PR number, and I'm very happy to share that. Now we are almost in a position where we are going to go by this sequential numbering. In the last meeting, we discussed about how to do that. So we came across a situation, and perhaps a solution for this is like EIP numbering will be done and managed by a Google Sheet, which is in person managed by the editors. So we will not be randomly allocating PR numbers, but the sequential numbers. So
yeah,
thank you for
so many wasted numbers. And I know I realized after I posted that this was already a hot conversation for editors for a long time. So I don't mean to take all the credit. I know that lots of people have been thinking about this for a while.
Right. Sometimes processes are delayed, and if we get a little bit of support or push from a community, that goes faster.
Right.
So yeah,
right.
Thank you. All right. I know we are almost close to the hour mark. Do you have any message for the validators community?
Not a big one. I mean, thank you. The beacon chain runs exceptionally well, better than we ever expected it to. We used to think before it launched, maybe like 80% would be like the average onlinedness, but it's like 99%. So 99.5 or 99.9. So y'all are killer. It's great. And keep an eye on testnets. The Neb testnets, Dankun testnets are coming up. So test your setups and get ready for the hard fork.
Very well said. So this is going to be the 4th upgrade, right? Altair, Bellatrix, and what was he?
Indeed. Capella, yeah.
Capella and this, Capella and this.
It actually is subtly really, really useful to help me remember them.
Right. Yeah, alphabetic order is helping there. Otherwise, for the EL level, we have to go back and check on everything.
You're like, when was DevCon? Where was DevCon?
Right. Very well.
And before that, it was chaos. Anyway.
Right. Very well. DannyR, we thank you for joining us on PEEPanEIP and talking about upcoming changes with respect to EIP-7045. From a strawman-proof sketch to a full-fledged beacon chain. Beacon chain, or the consensus layer, has evolved significantly, and we look forward to seeing the proposal on the testnet and finally on the mainnet with DanCon. On this note, thank you to all our YouTube viewers for watching, and podcast subscribers for listening to this special episode on DanCon. Should you have any question on this or any other topic, let us know at ETH Discord. Check out the description for more information. And we'll be back with another interesting talk. Until next time, keep watching, keep sharing, and keep loving Ethereum cat herders. Thank you, everyone.